Hi, hello everyone. The purpose of this video is this is kind of just a mock demonstration. We had a near miss a couple days ago. We had replaced some CTs at a fast food restaurant, and after doing so, after power was restored and some load was put back on, we wanted to do a full-blown site analysis to prove our work was valid. So we did that. We made all our connections. We successfully did a customer load test, and then we successfully did a CT test, testing the ratio and the burden. And then we went from there to do a phantom load test. So we went to connect our current jumpers from the bottom of X2 to the top of X1 with the test switch open, which we do, on a regular basis. And so I had successfully done that on C phase and on B phase, and went to do that on A phase, and I landed the bottom side of A phase. And then when I connected the top side of A phase to the X1 position, I got an arc. And what I had done was, instead of jumping onto the bottom side of the X2, I had actually inadvertently connected, and I know it's tough to see here, but I had inadvertently connected to the bottom side of B phase potential. So when I touched the jumper to the top side of X1, I had a short to ground. Our CTs are, well, they're tied back to the neutral bar. On our older installations, we no longer do that. We now ground them in the cabinet, which would have led to the same result. It would have been a short to ground. There was an arc, enough of an arc that it welded slightly the jumper to the test switch terminal. We stopped, pulled everything off, examined everything. Everything looked okay. We put all the leads back on and attempted to do the phantom load test. The lights would light up for potential and current on our test set, but we would continually get an error saying A phase current could not be controlled. So we tried that a couple different times. We powered the machine down, back up, still got that error. So then we started thinking, well, there was no open CT or anything because the test switch was open, so current had its normal bypassed path to go through. So we're thinking, well, maybe since we hit that on the top side, potentially we maybe had done something to the meter. We ohmed that out, which we had continuity, but it would take an awful lot to burn off one of the little bus bars in the meter. So we were thinking that maybe the little donut CT that wraps around that bus bar maybe had opened up, or maybe it was something at the board level on the meter itself. So we went ahead and swapped the meter, put the new meter in, attempted to test it, and had the same result. We would get our light indicators come on the test set. We could see current be applied on B phase and C phase, but it would not apply anything on A phase. So prior to that, I had even, with the jumpers removed, I think I still had the duct bill. No, I did not have the duct bills. I pulled the duct bills out, closed in the test switch on A phase, and made sure the meter spun forward, which it did. So I was fairly certain that our wiring was okay in the metering circuit. So then we thought, well, maybe there is a problem internally in the tester, and we got our metering software, MeterCAT, out and did a diagnostic on the new meter, and we showed no current on A phase again, just like we were seeing with the tester. And what we didn't think about is we had left the duct bill in. And so that's the biggest point of this video is I want to express is that when we pulled all of the test leads off but left the duct bills in and then closed the test switch, we in fact created an open CT. So as soon as we pulled that A phase duct bill out and ran our diagnostic again, then we seen current on all three phases. Now, it was not a huge issue on this particular service, as it was 120/208. It was a 600 amp panel. with roughly 120 amps per phase. But we often test 277, 480 services on a large industrial scale with 1,000, 1,500 amps easily. Had we repeated that same process there, I'm fairly certain it would have, could have been a ball of fire for sure. In no way do I blame the manufacturer of the test equipment or the test equipment itself. It was my mistake to cause that short, but it is certainly something that was very easily done and could easily be done by anybody else. That is the purpose of the video, is to just give everyone a heads up. I certainly never carelessly attached those jumpers, but never really thought about the potential to create an open CT in doing so. And like I said, that was only created when we left the duckbill in and closed the test switch, because something in fact had to open up inside the test set itself. We did not open that up and examine that. It's on its way back to be examined by the manufacturer, and we'll be gladly waiting to hear what they find. And we shared all this information with them as well. But anyway, just a heads up of what could have been catastrophic, I believe. Thanks.